Hi mathletes, Dave Staublin here. Let's do some good math. I want to talk about measures of central tendency when you have a set of data. Now, the type of data that we're talking about is quantitative, and so it is numerical data. The idea of measures of central tendency keys on this word central or center. In fact, what we're interested in is knowing where is the middle of the data. Well, I am positively certain that you have studied this before, and you know that there are three ways to find the middle of a data set. The first way is the mean, and then there's the median, and thirdly, there's the mode. Now, let's talk about the mean. In more advanced mathematics, we represent the mean using x bar. And we know that in order to get the mean, you add up all the data values and you divide by however many data values there are. And the way that we represent this mathematically is with the Greek letter sigma, which stands for sum or add them all up, and then x, which are all the data values, and then we divide by n, which stands for however many data values there are. And I'll show you how that works in our example below. The median is the middle value. If you line up all the data from small to large and find the number that's physically in the middle, that is the median. But there's a problem. If you have an odd number of data, then the median is the middle value. If you have an even number of data points, then it's the average of the two middle values. Now lastly, there is the mode. And the mode is interesting because sometimes the data has a mode, sometimes the data has more than one mode, and sometimes there's no mode whatsoever. And the mode is the data value that occurs most often. Okay, now that we know what those are, let's use the mean and the median to compare some data sets. So the first data set is A, and the numbers are 48, 49, 50, 51, 52. Now the way that we calculate the mean is by summing the value of the data, so 48 plus 49 plus 50 plus 51 plus 52. And if you do that, they sum to 250, and then we divide by the number of data points, 1, 2, 3, 4, 5. And you calculate, and the mean is 50. To find the median, we line up the data from small to large and find the middle value, and we find that it's 50. For our next data set, data B, the numbers are 33, 42, 50, 58, and 67. To find the mean, you add these values up, comes out to 250. There are 5 values, and so the mean is 50. They are arranged from small to large, and so the median is 50. Now, let's compare these two data sets. So if we look at A and B, they have the same mean and the same median. So the question is, if you looked at the mean and the median, saw they were the same, you could ask yourself, are the data sets the same? What do you think? Well, I think the answer is no, they are not the same. They have the same center, but they are different. How are they different? Well, to me, 48 to 52 is very compact. 33 to 67 is very spread out. So in my mind, they are different because of the spread. Okay? Now, let's throw another data set in here. Let's choose 48, 49, 50, 51, and 82. If we calculate the mean, the numbers add up to 280. There are 5 values, and the mean is 56. The median is the middle value. It is 50. So let us look at data sets A and C. In my mind, I'm seeing that they have the same median but a different mean. So if you consider the median, are the data sets the same? Well, let's look. 48, 49, 50, 51. Data A is 52. Data C has this number that is way far away from all the other data. We're going to call that an outlier. So, are the data sets the same? No, they are not. There is an outlier. And what does that outlier do? Well, if you look at the mean, as this number went out away from the center, it pulled the mean upwards. So in this case, the outlier pulled the mean upwards. All right, let's do one more comparison. Let's look at A, B, and C. So if we do that, let's consider the mode. We haven't talked about that yet. What's the mode for all these data sets? Well, it turns out that there is no mode because if you look at data set A, there's no value that occurs more than once, so they all occur the same amount of times. Same for data B, same for data C, so there is no mode. Okay? Let me ask you this. Would it be possible to create a data set with 5 values that had a mode equal to 50? And let me go further and see, is it possible to have the mode equal to 50 and the mean equal to 50? Maybe even further, could you have the mode equal to 50, the mean equal to 50, and the median equal to 50? Can you do it? All right. This is what I think. Mode 50. You could do 49, 50, 50, 51, 52. 50 occurs most often. The mode is 50. Next data. Can we do with the mode and the mean equal to 50? How about this? 49, 50, 50, 50, 51. Let's see. The mode is 50. If you add these all up and divide by 5, the mean is 50. And you know what? The median is also 50. So that one does all three. Can you come up with a data set that has mode 50, mean 50, median not 50? Well, how about if we do I'm not sure I can do it. I'll tell you what, I'll leave it to you to see if you can figure it out, and we'll follow up in our next class. All right, this video is long enough. I'm going to call it quits. There are measures of central tendency.